Okay. All right. Hi, everyone. I'm Chloe Roth. I'm the Giles County Agriculture Agent. And today we're going to be talking a little bit about water preparedness. And we have a presenter, Meredith Snyder, from the BSE lab on campus. She's a research associate and also helps with the Virginia Household Water Quality Program. So I'll turn it over to you, Meredith. And I think
Great.
I have to give you host permissions, don't I, to
Uh,
share your screen?
yeah, I just sent a request.
Okay, awesome. There you go.
Alright. Okay, does that look right?
Yes.
Can you see the presentation? Okay, great. So, like Chloe mentioned, my name is Meredith Snyder. I am a research associate at Virginia Tech with the Biological Systems Engineering Department, and we also have the Virginia Household Water Quality Program through the Virginia Cooperative Extension. And today I just wanted to talk a little bit about private water supply, drinking water testing, and a little bit about maintaining your private water supply if it's like a well, and what you can do if you have a spring, those kinds of things. So when I say water supply, a private water supply, that can be a couple of things. So it could be a well, a spring, or a cistern. And in the state of Virginia, there's about 1.6 million people, or about 20% of Virginians, relying on these types of water supplies. And the thing that's important about this is that private wells are not regulated by the Drinking Water Act, like public water or municipal water supplies are. So, where water gets treated in a treatment plan and it has all these limits that the EPA requires, all of that actually is not applied to private water supplies. And so, homeowners that own land or get their water from a private water supply are responsible for maintaining, addressing any problems, and testing their drinking water. So wells can be either drilled or bored, and they can range from about 20 to over 1,000 feet deep. And we recommend that these are located at least 50 to 100 feet away from sources of contamination. That could be, septic field, agriculture field, any sort of industrial plant, that kind of thing. And the key three components of a drilled well or bored well would be having proper casing, grouting surrounding the casing of the well all the way through down to the groundwater supply, and then a sanitary well cap to protect against any sort of surface contamination. For springs, so springs are formed along like a side of a hill or valley bottom, anywhere that groundwater intersects with the surface. And these can be highly susceptible to contamination from surface water because it is that interaction of groundwater and surface. And that can usually be either bacteria or nitrate. So we'd recommend treating spring water if that is your primary drinking water source. Other options are cisterns. So this is kind of like a big vessel used to collect and store rainwater, often off of rooftops. And it's not usually used for drinking water, but typically for like flushing toilets, those kinds of things. And that's just because there's issues with corrosivity. So rainwater tends to be more acidic. So like CO2 in the atmosphere kind of um, dissolves into the rainwater and makes it acidic. And there's also potential contamination from roofing materials or bacteria from the environment. So if that is a drinking water source, it also should be treated. So roadside springs are a common point of drinking water, especially in Giles County and around Virginia Tech area. And we do find coliform and E. coli present a lot of the time in these sources of drinking water. So we always recommend disinfecting this water, and that's as simple as putting 2 drops of bleach within 1 gallon jug of spring water, or you can boil water, and that will totally disinfect and protect you against any sort of bacteria that might be present. So what are things that may affect water quality within a well? There couple of different things to consider. So the first one would be the hydrogeology of the area, or that's a fancy way to say like how water moves through the bedrock and what types of rock are there. So in this region, there's a lot of limestone and sandstone, and limestone has a lot of calcium carbonate, magnesium, and those are things that can dissolve into the drinking water and make it hard. So if you've ever heard you had hard water, um, that's just calcium and magnesium forming like a film along all of your appliances if you get that like chalky white stuff. So that is from having limestone in the area, and that's indicative of the geology of the area. Another thing could be local land uses or service activities. So anywhere that like pesticides or fertilizer gets run off and is close to surface inputs to groundwater, that can impact the quality of your water, as well as any sort of like septic tank, any sort of like surface activity that could be putting sort of contaminants into the drinking water source. Also, well location. So like I mentioned, the septic tank, we want it to be, so far from where our drain field is located. We also want to make sure that the well is constructed properly and that it's properly maintained. So any cracks or anything that might allow surface or other contaminants to get into your drinking water. And then also plumbing and actual water treatment devices themselves can influence your water quality. So if you have lead or copper piping and your water and groundwater in the area is more corrosive, that can actually cause copper and lead to leak into your drinking water. And also if you have like a salt filter, that can introduce sodium and chloride into your drinking water as well. So what is the Virginia Household Water Quality Program? So that is the program that we're affiliated with. So we host drinking water clinics across 70 plus counties every year. And this is a confidential and more affordable testing option for people on private water systems. We test for 28 parameters. We will distribute kits, and the homeowners actually collect the samples, and it's coordinated transport with usually local extension offices. And then we bring those samples back to be tested at Virginia Tech. And then we will help with the interpretation of results and talk about different options for how you could treat your water if there is any issues. And our program has been running for over 10 years now. So I guess in 2008, our program started. We've run over 47,000 samples from across the state of Virginia. So the analysis that we do includes bacteria, so total coliform bacteria as well as E. coli, and then a suite of chemicals. These aren't everything, but it's the ones that we're typically most concerned about. So nitrate, copper, iron, manganese, sulfate, sodium, fluoride, lead, arsenic, how corrosive your water is, pH, how much dissolved solids there are, and then the hardness of the water. So this is what our sampling kit will look like. It has 4 bottles and a questionnaire to just get more information about like what kind of water system you have. And all of these 4 bottles are used to collect water from one source. So typically like your kitchen tap. So our first bottle is the first straw. So in order to kind of understand if there's any sort of leaching of metals from your plumbing into your drinking water, we ask that the water set in the pipes for about 6 hours. And then first thing in the morning before water is used in the rest of the house, you collect that first straw to see if there's any influence on the from the plumbing on your drinking water. The next one that we test for is bacteria. So you allow the water to flush for about a minute. You can like wash your hands in that time, and then you can collect water to determine if there's coliform bacteria. So that tells us if there's like surface contamination. So that's usually bacteria that's in the soil, that kind of thing. And then E. coli will tell us if there's any sort of fecal contamination. So maybe from the septic system, livestock nearby, that kind of thing. pH, conductivity, and ions will tell us how corrosive or alkaline, so how acidic or basic the water is. Corrosive is important to know, like if you do have lead or copper piping. And then we also measure ions from the sample, like fluoride and nitrate. And then finally, the flush bottle is like the first straw. It's metals and other elements, but after water is flushed through the system, so it's giving us an idea of how your actual like groundwater source is. So our results will come in 4 to 6 weeks after the sample date. And then we can help with the interpretation of results, consider different treatment options for solving some of the problems that may be found out. There's also education resources and also funding for helping repair or replacing wells that may be compromised, as well as we have funding for um, any sort of subsidy to actually get water tested if that is an issue. So when we think about different sources or issues of concern and within our drinking water, we have our house with our well nearby, and some of these contaminants can actually just be naturally in the groundwater or put into the groundwater from human activities. So a lot of these things are like I mentioned, the pH or corrosivity, hardness from like limestone, like iron, sodium, a lot of things that are just naturally within the groundwater. Then there's surface water contamination, like the nitrate and bacteria. So nitrate from maybe like fertilizer from agriculture, that kind of thing, and then bacteria from either soil, septic systems, that kind of thing. And then also the influence from plumbing or water treatment itself. So sodium, copper, lead, and bacteria. If any sort of like cracks or anything within the well are allowing bacteria to get in, that kind of thing. So where the contaminant comes from also affects like how we can deal with it and find treatment. So unfortunately, there's not one treatment that just kind of takes care of everything. That would be awesome, but usually we have to identify the problem and then treat that problem. So common problems that are found are the coliform bacteria, or E. coli, so that can be treated by a shock chlorination performed by a certified driller. The caveat with that is that if there is a source of contamination, like the integrity of the well is compromised, that will also need to be addressed because the chlorination will just clear the microbes in that point in time. You can also boil your water, use UV, or install an ozonation device. So I mentioned hard water that can be treated using a water softener, and a water softener is also good for iron and manganese up to a certain point. There's also aeration filters, oxidation filters that can be used for that issue. And then lead and copper is another big health concern. So if the pH is less than 6.5, you can consider increasing your pH with an acid neutralizer, reverse osmosis system, or an activated charcoal filter. So to kind of prevent a lot of issues that may be coming from actual the well itself, there's a couple of things that you can do considering the location, construction, and maintenance of your well. So ideally, like I mentioned before, you want your well to be located at least 50 to 100 feet away from sources of contamination and also upslope. So we don't want runoff of surface water collecting or draining into our well area. And then the area around the actual well itself, you can have a slope away from the well so that water isn't pooling or going down into your well. Also having that sanitary sealed well cap for a drilled well or a sealed concrete cover for a bored well. And then you can install backflow preventers as well. So here's just kind of a diagram that kind of that outlines having your casing about at least a foot above the ground surface, having it sealed with that sanitary weld cap. The ground slopes away from the casing, and then making sure that the whole casing is surrounded by a grout seal. For maintenance, we recommend testing your water. Ideally, you test for bacteria annually just to keep up with any sort of um, cracks or issues with surface and or surface contamination entering your well water, and then every other contaminants we recommend every 3 years. We recommend also keeping any well documents safe and accessible, so that includes past test results, your well completion report from the Virginia Department of Health, and any other sort of records that you acquire. If you have a well house, ensuring that that drain is clear of debris before any sort of flooding events. So we also recommend getting your well inspected if you are ever unsure of your well integrity. So if you've noticed any changes to your drinking water, we also recommend it if your well was constructed before 1992, just because that's when regulations went in place for actual well construction. Prior to that, there were no regulations. Um, and so we also recommend if you do test and you find a positive test for chloroform bacteria that indicates some sort of surface contamination. It's good practice to to get it inspected every 3 to 5 years, and then anytime there's a transfer of property. So we have a list of certified well drillers on our website. That's called Well Check, and basically it's just a resource for people to know that these drillers are certified to be checking systems for um, proper construction. Another consideration is properly abandoning wells. So there are a lot of health and safety consequences of unused wells left open to the surface, and that can be actually surface water getting down into the groundwater and impacting other people's wells, as well as it can be a danger to humans, pets, livestock, that kind of thing. And proper abandonment does require a permit from the health department and a licensed well driller. So this is just a good graphic to kind of show how uh, a not properly abandoned well can be a conduit for groundwater contamination. So here you see this abandoned well and surface water is getting into the groundwater and now impacting this person that now has a well in service. So that's why we recommend it should be plugged up by a licensed well driller so that it's not a health hazard. So this region I mentioned has a lot of limestone, and that's kind of called karst. And karst has a lot of caves and can create a lot of sinkholes. And that's because that limestone is super susceptible to being dissolved by water moving through the ground. And so that actually does make it a little bit more susceptible to land use related contamination, right? So if there's a hole going directly into the groundwater, surface water can easily get into the groundwater. So it is important to consider that in whether or not you get your water tested and where your water comes from. So I really like this graphic because it shows sort of how everything all is connected in a car system. So here, there's a lot of historic dumping of trash in sinkholes, but if you think of, cars and tires and those kinds of things and water, surface water is now able to get down into the groundwater, and that's connected also to, an area where there's a plugged sinkhole where septic system may drain into it, but then that's all getting into the groundwater for this person to now be getting their drinking water from the well. So this kind of shows just like how everything is all connected. And even though, this is so far away, it can still impact the groundwater way over here where this person's getting their well water from. And then here also kind of indicating that even though spring may be coming from a like fresh mountain water source, the actual groundwater connection to all of these other things is something to consider and testing your spring water as well. So another thing that's really prevalent in this area, especially of late, is flooding. So if you know you're in a flood-prone area, it's great to purchase and install a flood-proof well cap. And if you know kind of like where flood levels typically are, it's a good idea to extend your well casing above where flood levels will be, and also grade the ground to divert a water away from the entrance of the well. And also consider, where hazardous materials might be stored, so that, if they're above the flood level so that they're not getting into the surface water to contaminate other sources. So we always recommend to be prepared. So if you um, have a well, consider installing a generator to power your well pump and other important appliances. Store drinking water about a gallon per person or pet per day, and plan for about 3 days if you know something's coming. You can also fill your bathtub and those kinds of things for non-drinking water uses like flushing the toilet. If you know a flood or storm is coming, you can disconnect your water treatment equipment and turn off your breaker. You can plug in any plumbing opening when the equipment is disconnected. If there is not a flood-proof well cap on your well, you can wrap it with heavy-duty plastic and waterproof tape to prevent any floodwater from getting in the best that you can. And also wrap electrical boxes, outlets, those kinds of things that are not waterproof. So during the storm or after, we recommend not using your well water if flooding has for sure happened at or near your wellhead. It's a good idea to have a drilling contractor pump out your well to remove any debris or sediment. Because if you turn on your well and that's in there, there may be damage done to your pump. Also have a well drilling contractor shock chlorinate if you know the well has been flooded. And then it's a great idea to go ahead and get tested for bacteria nitrate at a minimum, just to know that if it has been compromised by the flood, you're not using it for drinking or cooking. And then um, doing that after shock chlorination to make sure that your well was not compromised at all from the flooding event. We do have a lot of information on our website. So this is an infographic we recently put out that talks about things that you can do for your well before and after a flooding event. And we also have information if you have a septic system. So there's a link to our website at the end of this presentation that if that is something that you would like to have on hand, I think it's a great resource. And with that, that's pretty much all I have for our private drinking water presentation. If you have any questions, you can go to our website, the wellwater.bse.bt@edu. Also, you can reach out to me or my supervisor, Erin Ling, and we're always happy to answer any questions related to drinking water or private water drinking sources. So I'll turn it back to you, Chloe. Thanks. Again, stop sharing.
I'm muted. Thank you
Okay.
so much, Meredith.
Yeah, no problem.
Okay, I'm gonna stop our recording.